Imagine waking up tomorrow and every single fuel source on Earth has suddenly just vanished. Poof! Your phone is dead. Cars are stopped in the streets. No internet, no food delivery, nothing. Sounds like a crazy sci-fi disaster movie, right? But here's the scary part. Most people have absolutely no idea how dependent we are on this invisible, non-stop energy battle happening right under our noses. Welcome to today's Explainer, guys. I am super hyped because we are jumping straight into the ultimate energy showdown. We're breaking down the fuels that power your entire life right now and the ones that are going to totally define our future. Let's get into it.
But wait, before we get into the heavy stuff, I've got a crazy riddle for you. What does a tiny 6-gram pellet, literally something small enough to balance on the tip of your finger, have in common with an entire massive ton of coal? Seriously, think about it. I'm going to reveal the mind-blowing answer in just a few minutes, and I promise you it is going to completely change how you look at power.
So, here is our game plan for today. 1. The definition of fuel. 2. We'll meet the contenders. 3. The global energy surge. 4. The efficiency battle. 5. Reliability and cost. And finally 6. Emissions and the future.
All right, Section 1. The definition of fuel. So what actually is fuel? Well, scientifically speaking, it's just a substance that releases usable energy when it goes through either a chemical reaction, like, burning, or a nuclear reaction. And that energy doesn't just vanish, it transforms. It turns into mechanical energy to spin your car's engine or electrical energy to keep your Wi-Fi running. It is literally the magic ingredient that makes the modern world go round.
Now, if we were playing a game to invent the absolute perfect ultimate fuel, it would need to have some serious superpowers. We've got a checklist here. It needs to be readily available, it needs to be dirt cheap, it should burn easily and release a massive amount of heat. Obviously, it needs to be easy to transport around safely, and ideally, it shouldn't produce a ton of harmful byproducts. So as we meet our energy contenders today, keep this scorecard in mind. Which one do you think is going to win?
Let's move to Section 2. Meet the contenders.
In corner number 1, we have the reigning heavyweight champion of the last 100 years, fossil fuels. We're talking coal, crude oil, and natural gas. Nature literally spent millions of years crushing ancient organisms underground to make these. They are amazing at releasing huge amounts of energy. But here's the crazy part. We are using them up incredibly fast. They are strictly non-renewable. Once we burn through our reserves, guys, that's it. They're gone for good.
In the next corner, we've got a really cool alternative, biofuels. What if fuel could just come from plants? Unlike fossil fuels that take millions of years, biofuels come from stuff that was living practically yesterday. We're taking things like sunflower oil, sugarcane, or literally waste cooking oil right from the fryer and turning it into fuel to drive your car. It's an awesome way to recycle carbon that's already moving around in our active ecosystem.
And finally, let's talk about the fuel that literally sounds like science fiction, nuclear fuel. This isn't about burning stuff. Materials like uranium release totally insane amounts of energy by actually altering the nucleus of an atom. There's fission, which splits atoms apart, and fusion, which smashes them together. Fun fact, fusion is literally what powers the sun. But down here on Earth, our power plants mainly use fission to keep the lights on.
All right, Section 3. The global energy surge.
We all know the world needs more energy every single year, but our current setup? It's pretty shocking. Right now, a massive 74% of the entire world's electric power comes from thermal power plants, mostly burning those fossil fuels we just talked about. Renewables like wind, hydro, and solar, they only make up 26%. We are seriously, heavily addicted to combustion just to keep civilization running.
And if you thought we were backing away from burning stuff, get ready for this number, 750. According to the World Resources Institute, there are literally 750 brand new coal power plants currently being planned across 50 different countries right now.
So where exactly is this massive explosion of coal happening? Well, about 80% of those planned plants are concentrated in just 5 Asian countries: China, India, Indonesia, Japan, and Vietnam. This adds up to an expected 300 gigawatts of electric power. The developing world is growing super fast, and right now, coal is just the quickest, most familiar way to feed that massive hunger for electricity.
Section 4. The efficiency battle.
Okay, remember that wild riddle I gave you at the very beginning? The tiny 6-gram pellet versus the literal ton of coal? Well, the wait is over. That little 1-inch cylinder right there in the middle of the screen, that is a uranium fuel pellet, and the amount of energy packed inside this thing is just beyond belief. Look at this math. That single, tiny 6-gram pellet of uranium holds the exact same energy potential as an entire ton of coal. It's the same energy as 1,200 gallons of oil or 17,000 cubic feet of natural gas. Just picture the logistics here. You could hold a pellet in your hand versus having to load up massive freight trains with tons of heavy coal just to get the exact same amount of power. In the efficiency battle, nuclear fuel is basically playing with cheat codes.
Moving on to Section 5, Reliability and Cost.
Okay, but a fuel is only good if it actually works when you need it, right? We measure this with something called capacity factor, which is basically how often a power plant is running at its maximum power. Look at this chart. Nuclear plants are absolute beasts. They run reliably at full capacity 92.5% of the time. Coal is way down at 40.2%, wind is at 35.4%, and solar is at 24.9%, mostly because, the wind stops blowing and the sun goes down. When you need guaranteed power 24/7, no questions asked, nuclear absolutely crushes the competition.
But wait, isn't nuclear super expensive? Well, let's look at the actual receipts. Building a plant costs a lot up front. Sure, but when you look at the total average cost to generate electricity, which includes operations, maintenance, and the fuel itself, a totally different story pops up. This is measured in mils per kilowatt hour, which is just a fraction of a US cent. Hydro is the cheapest at 10.29, but nuclear is surprisingly competitive at 24.38. It actually beats out the combined average of gas turbines, solar, and wind, which sits all the way up at 31.76. So over its lifetime, nuclear is remarkably cheap.
Section 6. Emissions and the future.
Now for the biggest question of all, the environment. When you look at the grams of greenhouse gases emitted per kilowatt hour, the difference is brutal. Coal and natural gas are pumping massive amounts of CO2 into the atmosphere to meet our crazy energy demands. But look down at the bottom. Solar, wind, and nuclear are basically sitting at near zero. They are practically emission-free in comparison.
And nuclear has this crazy hidden superpower that most people don't know about. Not only is uranium super abundant in the Earth's crust, meaning we won't run out anytime soon, but you can literally recycle it. Yep, spent nuclear fuel can be reprocessed and used all over again to make even more power. Good luck trying to do that with a pile of coal once it's turned into ash and smoke.
So, where's all this heading? Check out the road to 2050. As of May 2021, we already had 52 new nuclear reactors actively under construction around the world. And looking out to 2050, experts project a massive 26% growth in global nuclear capacity. Just like the coal boom we talked about, a ton of this new nuclear expansion is happening right now in Asia, especially in places like India and China, as they rush to power up their growing grids.
So, what's the big takeaway here? Our traditional fossil fuels are rapidly declining, but the human demand for power is literally exploding. Every light switch you flip, every TikTok you scroll, every meal you cook, fuel is working behind the scenes. We've seen today that nuclear offers totally insane energy density, unbeatable reliability, competitive costs, and basically zero emissions. Understanding all this isn't just a science lesson, it is literally about figuring out how modern civilization is going to survive. So I'll leave you with this. As the era of abundant fossil fuels fades away, is a massive shift toward nuclear power the only real way to fill the void and keep the lights on? Let that sink in. Thanks so much for hanging out with me for this explainer. Keep asking questions, keep learning, and I will see you in the next one.